Lesson 4 is on dilations. It's the last of the transformations that we're going to do. In the first 3 lessons, we've talked about translations, reflections, and rotations. They all have very similar properties. Dilations, you're going to notice maybe a little difference here. A dilation is when you make an image bigger, or you enlarge it, or you make it smaller. Okay? Or we call that a reduction. And so if you take a look at the picture over here, we have triangle ABC. This is our pre-image. This is our original image. And they have enlarged it. Okay? The enlargement is called a scale factor. So when they will give you a specific scale factor, they will tell you what you have to do to make it bigger or make it smaller. They represent this scale factor by using the letter K. So an enlargement happens when your K, or your scale factor, is greater than 1. So if your scale factor is 2, 3, 4, 5, and so on, you're going to get a bigger image. If your K, or your scale factor, is a fraction or a decimal, it is going to make your pre-image smaller. Okay, it has to be in, if you look right here, it has to be in between 0 and 1. So any fraction or decimal. If you have a scale factor that is 1, it's going to stay exactly the same size. So a dilation here, the shape stays the same shape. For if it's a triangle, it's going to stay a triangle, but the size will change. Okay, very simple to do. If you look down here at your symbols, here's your coordinate, here's your ordered pair for a point on your figure. All you have to do is take each coordinate, each ordered pair, x and your y, and multiply it by your scale factor. Okay? If you take a look here, it says the pre-image and the image are the same shape, but not the same size. Again, it'll probably be enlarged, or it will get bigger, or it's going to be reduced, or a reduction. It's going to be smaller. Let's take a look at an example. It says the triangle has vertices A, B, and C. Find the coordinates of the triangle after a dilation with a scale factor of 4. So if we have a scale factor of 4, that means that since it's greater than 1, it's actually going to be an enlargement. Okay, we're going to make our figure bigger. Again, all we have to do is take our points and multiply each point by 4. So A is 0, 0. We take 0 times 4 and 0 times 4, which gives us 0, 0. That point's going to stay the same. 8 and 0, if we take 8 times 4, we get 32. 4 times 0, we get 0. So here's our new B. So this is A prime, this is B prime. Then we take C. C times 4, or 3 times 4, negative 2 times 4, gives us 12 and negative 8. So right here, these are our new points. Okay, and we plot them. That's our new image. Okay, let's try one on your own. The got it problem A says it has a figure has vertices W, X, Y, and Z. Okay, find the coordinates of the figure after a dilation with a scale factor of 2. Okay, so they're telling us the scale factor right here is 2. So we need to take each one of these points and multiply the x by 2 and the y by 2. So right now, pause the video and show your work. Okay, let's see how you did. Okay, here are our original points. Okay, W, X, Y, and Z. To get our new figure after our dilation, we have to take each one of these points and multiply it by 2. So I took my x values and multiplied them by 2. I took my y values and multiplied them by 2. So therefore your new points should be W prime is negative 4 and 8, X prime is 2 and 8, Y prime is negative 6, negative 2, and Z prime is 6 and negative 2. Okay. Again, I just took each one of my coordinates and multiplied it by 2. And it would be the same thing if it was a fraction. If it was 1/2, I would take each one and multiply it by a half. Just whatever that scale factor is, that's all you have to do is multiply. Okay. Let's look at example 2. A figure has the vertices J, K, and L. So we have a triangle. Graph the figure and the image of the figure after a dilation with a scale factor of 1/2. Okay, so now since we're in between 0 and 1, this is actually going to be a smaller figure. Okay, now since they gave you the vertices, all you have to do is like what you just did in your got it problem. Take each one of these points and multiply it by 1/2. That's what they did here. Okay, so they took each one of these points, multiplied it by 1/2, and they got their new coordinates, which are right here. Then all you have to do is plot your new points. Here's J, K, and L prime, and you get your new figure. Okay? Alright, so do your got it problem again. You have a coordinate grid, plot F, G, H, and I. Then you're using a scale factor of 3. So you're going to have to multiply each one of these points by 3 to get your new image. So pause the video and try got it problem B. Alright, let's see what you did. Okay. Here's our original image on the inside, our smaller one, F, G, H, and I. We took and we multiplied it by a scale factor of 3. Okay, so you took each one of these points, multiplied it by 3. Here's your new image. Okay, if you take a look, this is the other way you can do it. If you know F and I, that is 1, 2. Take 2 times 3 and you should get 6. So this new line should be 6. 1, 2, 3, 4, 5, 6. IH is 1, 2, 3, is 3 units long. If we go 3 times 3, we get a length of 9. Okay, and that's the other way you can do it as well. But it's going to be easier if you just take your points so you know exactly, because it's hard to do with diagonals. Okay. Our last example is just working backwards, just like what we did with the other transformations. They're going to give us the new image and the pre-image. They're going to give us the new image and the pre-image, and they want to know what is the scale factor. So again, they're going to give us the new image and the pre-image. We have to find out what the scale factor is. Okay, very simple to do. Through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? All we have to do is make a ratio. Okay, we know that the image is getting bigger. Okay, so we put 11.25 on top. We divide it by 0.25, and when we divide it, we get 45. So the scale factor is 45. It's 45 times bigger, okay, using the microscope. Let's take a look at your got it problem. Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? Well, all we need to do, what we're doing is we're going to take 3 inches and we're enlarging it to 7.5 inches, and we're taking 5 inches and we're enlarging it to 12.5 inches. So there's 2 ways you can do it. Okay, you can take 7.5 inches divided by 3. We're making our ratio 7.5 over 3. Or you can take the other side, 12.5, and divide it by 5. Either way, either ratio will give you the correct dilation. Again, we are enlarging it, so it has to be it has to be greater than 1. So if you take 7.5 divided by 3, or if you take 12.5 divided by 5, it should give you 2.5. So 2.5 is our scale factor. Okay? Now what I want for you to do, go ahead and try the guided practice problems, and we'll check them tomorrow in class.